This is a series of tutorials for building a simple online game using Microsoft SignalR and React. In the last video, I discussed how to create a new dotnetcore web API application and how to migrate the user table to the database. In today's lesson, I will guide you on how to code the user authentication endpoint of the API application. This endpoint will interact with user data in the database. And finally, in this video, I will guide you on how to hash the password before storing it in the database and how to verify the hashed password with the original password. Let's go back to our API application. First of all, I will delete all unnecessary files of the pre-generated weather forecast endpoint. First, I will create a file for the user endpoint, which will be named user controller. This file should be located in the controllers folder. Since we will not be changing the default definitions of the controllers, this is the appropriate location for the new file. Create the user controller class, inheriting from the controller base class of ASP.NET Core MVC. We want to define the root for this user API endpoint. In the root attribute, I will specify API controller like this. This will allow us to access the endpoint using API user. Additionally, we need to apply the API controller attribute to configure the behavior of this class. To communicate with the database, we need to inject our DB context class. To do that, I will create the constructor and inject the DB context class. After that, I am going to create our login and register endpoints. Let's start by creating the login endpoint. It will be an HTTP post method with the endpoint root as login, so the HTTP post attribute will be like this. Next, let's create a public method for login that returns a task of iAction result. For the login endpoint, we need to receive the username and password from the user in the HTTP request body. To achieve this, we have created a user model. We will import this user model into our user controller and name it user object to represent the user object received from the request body. We will return an OK result to indicate a successful login attempt. Next, I will proceed to create the register endpoint. It will follow a similar structure as the login method, with the only change being the endpoint root, which will be register. Before proceeding with user registration, we need to check if the request is null or empty. If it is, we will return a bad request response. After validating the request, I will add the user to the database and save the changes. After successfully adding the user to the database, I will return an OK response with the message, "Register success." In the login endpoint, similar to the register endpoint, we will check if the user object is null. If it is, we will return a bad request response. Next, we need to check if the user exists in the database. We can use the first or default method to find the user. If the user is not found, we will return a "user not found" result. After confirming that the user exists in the database, we need to check if the password matches. We will use the same method as before for basic validation. If the password matches, I will return an OK response with a message indicating that the user is logged in. Let's test our endpoints using the Swagger development server. I will open Swagger using this link, and then I will proceed to register a user. We do not need to provide an ID for the user. By marking the user-ID property with the key attribute, it will automatically generate the next ID for the user. Provide the username and password, and I will execute the registration request. Once executed, you will see the server response indicating "Register success." Let's quickly check the database to see if the user has been added. Now you can see that the registered user is indeed in the database. Let's proceed to the login endpoint to verify the user login method. You can see the response indicating that the user has successfully logged in. Next, let's see what happens when the password is incorrect. And as you can see, the response indicates "not found" with a message stating that the password is incorrect. Let's provide a different username that is not in the database. As expected, the response indicates "not found" with a message stating that the user was not found. Login and register endpoint routes are functioning correctly. However, the user passwords are currently stored in plain text format in the database, which is not secure. To enhance security, we need to hash the passwords. Let's proceed with password hashing. First, we need to check if the username is already in the database. After verifying the username's availability, we need to check the strength of the password. Once the password strength is validated, we can proceed with password hashing. First, we will check if the username is already taken. To do this, we will search the user list in the DB context to see if any user's username matches the username in the request user object. If a username already exists in the database, I will return a bad request result with the message "username already exists." Next, we will proceed to check the strength of the password. Let's create a private method for checking the password strength. This function will take the password as input. To handle password error messages, I will initialize a new instance of the StringBuilder class. The password length should be a minimum of 8 characters. If the password length is less than 8 characters, we will append the error message, minimum password length should be 8, to the StringBuilder instance. Additionally, we will append a new line character for formatting. Let's check if the password is alphanumeric. We can achieve this by using the regex.isMatch method. Finally, we will check if the password contains special characters. Once we have checked all the password criteria, we will return the error strings. In the user registration process, we will check the password strength by calling the checkPasswordStrength function. If this function returns any strings, it indicates that there are password strength errors. We will return these error messages to the user. Let's check the password strength method to ensure that it is correctly validating passwords. Let's test the register user endpoint by providing a username and the password of ABCD. As expected, the response indicates a bad request with error messages. Then I will change the password to one without special characters. You can see that the error message indicates this issue. Let's also check the case where the username already exists in the database. As expected, it also indicates the error message. Next, I will proceed to hash the password. To do this, I will create a new helpers folder, and within it, I will create a file named passwordhashing. Inside this file, create the public class name passwordhashing. Here, we initialize a static instance of RNG crypto service provider, which is used for generating cryptographically strong random numbers. Then, I will declare a constant variable salt size with a value of 16. It determines the size of the salt used in the password hashing process. Similarly, this line declares a constant variable hash size with a value of 20. It determines the size of the hash output. Here, we declare another constant variable iterations with a value of 10,000. It specifies the number of iterations used in the password hashing process. Let's define a public static method named hashPassword, which takes a string parameter password and returns a string of the hashed password. Let's create a salt using strong random bytes with a size equal to the specified salt size. Here, we declare a byte array variable named salt, which will hold the randomly generated salt. This line generates a random salt of the specified size using the RNG crypto service provider and assigns it to the salt variable. Here, we initialize an instance of RFC-derived bytes with the password, salt, and iterations. This class implements password-based key derivation functionality. Generates the hash of the password using the RFC-derived bytes instance and stores it in the hash variable. Here, we create a byte array named hashbytes to hold the concatenated salt and hash. Then copies the salt bytes into the hash bytes array starting at index 0. Then copies the hash bytes into the hash bytes array starting at index salt size. Here, we convert the combined salt and hash bytes to a base 64 string representation. Finally, we return the base 64 string representation of the hashed password. Let's continue with the explanation of the verify password method. Let's create a public static method named verify password, which takes two parameters, a string password, the password to verify, and a string base 64 hash, the hashed password stored in the database. It returns a Boolean value indicating whether the password matches the stored hash. We decode the base 64 encoded hashed password string, base 64 hash, into a byte array named hash bytes. And create a new byte array named salt with the same size as the salt used during hashing. Then copy the first salt size bytes from the hash bytes array, which contain the salt, into the salt array. Next, Let's generate the hash of the input password using the RFC-derived bytes instance and store it in the hash array. We start a for loop to iterate over each byte of the hash. Inside the loop, we compare each byte of the stored hash, starting from index salt size, with the corresponding byte of the generated hash. If any byte doesn't match, we know the passwords are different. If we find any byte mismatch, we immediately return false, indicating that the passwords do not match. If the loop completes without finding any mismatch, it means the passwords match, so we return true. This method efficiently verifies whether a given password matches the hashed password stored in the database. It provides a secure mechanism for password authentication, ensuring that passwords are not stored in plain text and are resistant to various attacks. Then let's add the hash password method to the user controller. In the register method, before storing the user password in the database, I will hash the password and save the hashed password. Let's check these changes. Go to the Swagger index page and register a new user. User registration was successful. Let me show you what the password looks like now in the database. Now you can see that the user password has been encrypted. Before hashing, it shows the password value, but now it's encrypted. Okay, let's add the password verification to the login method. Let's check whether the provided password matches the hashed password stored in the database. Verify password method takes two parameters: the password provided by the user.obj.password, and the hashed password retrieved from the database, user.password. If the passwords do not match, it means the user provided an incorrect password. In that case, the method returns a not found response along with a message stating, password is incorrect. Let's quickly check the password verification. I have already registered some users. There seems to be an error because even with an incorrect password, the user can still log in. Let's review the code again. The issue lies in the fact that the password verification is not returning true when it should. I forgot to include the not command in the verification. Now you can see it works fine. Today, I discussed how to create the user controller endpoint, as well as password strength checks and password hashing. In the next video of this tutorial series, I will cover front-end development, creating a project using React with TypeScript. After setting up the basics, I'll delve into the use of global context and reduces in React.js. Please stay tuned with me throughout this series. You'll learn a lot. If you like my videos, please subscribe to the channel, and don't forget to hit the like and notification icons. Thank you.